A rare visitor from deep space is flying through our solar system. The object, now officially named 3I Atlas, is mind-blowingly huge and moving at impossible speeds. Could this colossal traveler from another star hold secrets that could change everything we know about our place in the universe? Some scientists are terrified by what NASA's data is revealing. The breaking discovery. The astronomical community was stunned when the Atlas telescope in Rio Hurtado, Chile detected a mysterious object moving at incredible speed through our solar system on July 1, 2025. Initially designated A11PL3Z, this faint blip at magnitude 18 quickly drew international attention from observatories worldwide. Follow-up observations by multiple telescopes confirmed something extraordinary. This wasn't a typical space rock but the third confirmed interstellar visitor, now officially designated 3I Atlas. Its hyperbolic trajectory and extreme velocity immediately suggested an origin far beyond our solar boundaries, forcing astronomers to reconsider existing models of interstellar object behavior. The object's sudden appearance sparked both excitement and genuine concern within the scientific community, as its unprecedented size and velocity patterns baffled even the most experienced researchers. NASA immediately mobilized its network of ground-based and space-based telescopes to monitor this cosmic traveler closely, launching one of the most intensive observation campaigns in modern astronomy. The extraordinary nature of this discovery has reignited passionate debates about the possibility of extraterrestrial technology passing through our celestial neighborhood, with some scientists expressing private concerns about what this visitor might represent for humanity's cosmic security and understanding of our place in the universe. The discovery story. How does one spot a needle in the cosmic haystack traveling at impossible speeds? Between June 25 and July 1, 2025, the continuous robotic surveys conducted by the Asteroid Terrestrial Impact Last Alert System began detecting an unusual object with properties unlike anything previously recorded in astronomical databases. Located in challenging viewing conditions near the constellations Serpens Cauda and Sagittarius, the object's initial faint appearance made it extremely difficult to track against the crowded star fields near the galactic center. The automated Atlas system's sophisticated algorithms identified this fast-moving visitor, initially catalogued as A11PL3Z, immediately triggering alerts that attracted urgent attention from professional astronomers across the globe. The object's clearly hyperbolic trajectory and extraordinarily high velocity indicated definitively that it was interstellar in origin, prompting an unprecedented level of international collaboration for detailed follow-up observations. Advanced telescopes from the Canada-France-Hawaii Observatory, Lowell Discovery Telescope, and numerous other facilities provided crucial confirmation data, sharing precise positional measurements through secure astronomical networks. This coordinated global effort enabled detailed orbital calculations that definitively cemented 3I Atlas's historic status as humanity's third confirmed interstellar intruder, following the groundbreaking discoveries of 1I Oumuamua and 2I Borisov that forever changed our understanding of cosmic visitors. A stranger in our midst. What makes 3I Atlas so fundamentally different from everything else in our solar system that scientists are genuinely unnerved? This cosmic stranger immediately distinguished itself through characteristics that challenge our basic understanding of interstellar objects and natural physics. Moving at an absolutely staggering speed of approximately 58 kilometers per second relative to our Sun, it dramatically exceeds the velocities of all previous interstellar visitors, including 1I Oumuamua at 26 kilometers per second and 2I Borisov at 32 kilometers per second. Despite its incredible distance, the object maintains sufficient brightness around magnitude 18 to enable telescopic detection and detailed study by major observatories worldwide. Unlike typical solar system objects that follow predictable elliptical orbits, 3I Atlas traces an extreme hyperbolic trajectory with an unprecedented eccentricity of 6.141, mathematically proving it is gravitationally unbound and destined to exit our solar system forever. Perhaps most disturbing to researchers is the object's premature cometary activity, forming a visible coma and distinctive tail despite being over 4.5 astronomical units from the Sun, much farther than any known comet species begins showing activity. This combination of impossible velocity, extreme trajectory, and anomalous behavior has created profound unease among scientists, with some privately questioning whether 3I Atlas represents something far more extraordinary than a simple frozen rock from interstellar space. The predecessors. So how did humanity suddenly transition from never seeing interstellar objects to detecting 3 in just 8 years? Well, our cosmic awakening began with the shocking discovery of 1I/Oumuamua in October 2017 by the Pan-STARRS telescope in Hawaii. This elongated asteroid-like visitor absolutely stunned astronomers with its mysterious acceleration and complete lack of expected cometary features. The enigmatic object sparked some pretty intense scientific debates about whether it had natural or artificial origins, with a few researchers even suggesting it might represent alien technology. The conversation took a new turn with the August 2019 discovery of 2I/Borisov by amateur astronomer Gennady Borisov from Crimea. This time we saw a more conventional interstellar comet that behaved remarkably similarly to comets from our own solar system, giving researchers their first real chance to analyze pristine materials formed around distant stars. Now, the arrival of 3I/Atlas in 2025 marks the latest and most puzzling chapter in this rapidly expanding field, combining disturbing elements from both predecessors while introducing entirely new anomalies. With a significantly larger estimated size than both previous visitors, clear cometary activity, and record-breaking velocity, 3I/Atlas really does defy easy categorization. Each successive discovery has just exponentially expanded our understanding of the galaxy's vast population of wandering objects ejected from distant planetary systems, suggesting a dynamic and honestly potentially threatening interstellar environment filled with cosmic refugees from stellar catastrophes. The cosmic journey. So where exactly is 3I/Atlas headed? And should humanity be concerned about its trajectory through our solar system? Well, this interstellar wanderer follows a precisely calculated path that brings it uncomfortably close to multiple planets, though it keeps enough distance to avoid being captured by gravity. It was first detected approaching from a tough viewing angle, which kept it hidden near the sun's glare. The object's hyperbolic orbit will carry it to perihelion on October 29, 2025, passing closest to our star at 1.36 astronomical units. That's roughly 203 million kilometers away. While 3I/Atlas will never get closer than 1.8 AU to Earth, so our planet is safe from any kind of direct collision. Its trajectory aligns almost perfectly with our solar system's ecliptic plane. Astronomers calculate that's only a 0.2% probability of happening by random chance. This suspicious alignment gives the object optimal viewing opportunities of all the major planets, including close approaches to Mars and Jupiter, which would be just ideal for reconnaissance purposes. The path offers some unprecedented opportunities for detailed study by existing planetary orbiters and Earth-based telescopes, but it also raises some unsettling questions about whether such precise planetary encounters could really result from just natural gravitational interactions. After its solar passage, 3I/Atlas will begin its permanent departure from our cosmic neighborhood, carrying whatever information it may have gathered back into the vast emptiness of interstellar space, never to return to our vicinity again. A scientific goldmine. Why are astronomers calling 3I/Atlas the most scientifically valuable interstellar object ever detected, despite their concerns about its true nature? This cosmic visitor presents just unparalleled opportunities for studying authentic interstellar materials and processes with a level of detail and duration we've never had before. With its substantial estimated size ranging between 1 and 12 kilometers in diameter, potentially making it the largest confirmed interstellar object and sustained cometary activity producing analyzable dust and gas, researchers worldwide are really mobilizing to extract maximum scientific value from this fleeting encounter. The object's extended visibility period means that major observatories and space telescopes, including the James Webb Space Telescope and Hubble Space Telescope, can collect high-resolution spectra and detailed imagery over several months, instead of the brief observation windows we're used to with interstellar visitors. Such comprehensive data provide invaluable insights into primordial materials and formation processes from other star systems, potentially preserved unchanged for billions of years during the object's journey through interstellar space. The massive international collaboration studying 3I/Atlas really exemplifies modern astronomy's remarkable capability to rapidly coordinate global resources and expertise when investigating these transient cosmic phenomena. Scientists actually anticipate that discoveries from this visitor could fundamentally reshape our understanding of planetary formation, the prevalence of organic compounds throughout the galaxy, and the dynamic processes that shape stellar systems. All in all, 3I/Atlas is shaping up to be an unprecedented scientific treasure trove, with implications extending far beyond our solar system's boundaries. Unanswered questions. What fundamental mysteries about 3I/Atlas continue to terrify scientists despite months of intensive study and observation? The most experienced researchers admit that critical questions remain frustratingly unanswered, creating unprecedented uncertainty in the astronomical community. Scientists struggle with determining the object's precise dimensions, as the dense coma extending up to 24 kilometers across completely obscures the solid nucleus, leaving size estimates ranging wildly from 0.8 to 11 kilometers in diameter. The object's anomalously early cometary activity, beginning at over 4.5 astronomical units from the Sun, directly contradicts established thermal evolution models for icy bodies, suggesting either exotic ice compositions or unknown internal heating mechanisms. Spectroscopic analysis reveals compositional anomalies that defy conventional explanation, with water-ice signatures that don't match expected patterns and electromagnetic emissions that hint at non-natural materials or energy sources. Perhaps most disturbing is the object's apparent structural integrity, despite an estimated age exceeding 7 billion years of interstellar travel, which should have resulted in significant fragmentation and erosion from cosmic radiation and micrometeorite impacts. Advanced computer modeling has failed to adequately explain how natural formation processes could produce an object with 3I/Atlas's specific combination of characteristics, forcing scientists to confront possibilities that challenge fundamental assumptions about cosmic physics and the nature of interstellar space, leaving the scientific community genuinely uncertain about what they're actually observing. The alien question. Could 3I/Atlas represent humanity's first confirmed encounter with extraterrestrial technology? And, why are some scientists genuinely terrified by this possibility? This question has sparked honestly unprecedented controversy within the astronomical community, dividing respected researchers and really challenging the boundaries of acceptable scientific discourse. Prominent Harvard astrophysicist Professor Avi Loeb has courageously argued that the object's statistically impossible trajectory, precise planetary encounters, and anomalous physical characteristics strongly suggest artificial, rather than natural origins, potentially representing advanced reconnaissance technology from an extraterrestrial civilization. Loeb emphasizes that the mathematical probability of 3I/Atlas's trajectory allowing optimal study of multiple planets approaches 0 for random natural occurrence, suggesting deliberate design for comprehensive solar system reconnaissance. His analysis points to the object's strategic timing, noting it remains hidden behind the Sun during closest approach while deploying what appears to be controlled outgassing for course corrections or communication purposes. However, the majority of mainstream scientists express deep skepticism about artificial origin theories, emphasizing the importance of rigorous scientific methodology and warning against premature conclusions that could undermine public trust in astronomical research. Critics argue that extraordinary claims require extraordinary evidence, and current observations, while puzzling, don't provide definitive proof of intelligent construction. Nevertheless, the artificial origin hypothesis continues gaining credibility as conventional explanations fail to account for 3I/Atlas's unprecedented characteristics, forcing the scientific community to confront the, terrifying possibility that we may be witnessing our first confirmed contact with alien intelligence deliberately studying human civilization. Observing the visitor. How are the world's most powerful telescopes being mobilized to unlock the secrets of 3I/Atlas, and what are they revealing that has scientists so concerned? Astronomers worldwide have initiated the most comprehensive interstellar object observation campaign in history, deploying virtually every available telescope and detector system to study this mysterious visitor before it disappears forever. Ground-based observatories including the Gran Telescopio Canarias, Palomar Observatory, and Gemini South provide continuous optical and near-infrared imaging, while space-based platforms such as the James Webb Space Telescope, Hubble Space Telescope, and various planetary mission spacecraft contribute unprecedented high-resolution data across the electromagnetic spectrum. This coordinated international effort involves over 30 observatories and research institutions sharing data in real time, creating the most detailed observational dataset ever assembled for an interstellar object. Sophisticated spectroscopic monitoring reveals temporal changes in outgassing patterns and dust production that suggest controlled rather than random thermal processes, while polarimetry studies indicate surface properties inconsistent with typical cometary compositions. Radio telescope arrays including Arecibo and the Very Large Array continuously monitor for potential electromagnetic emissions or communication signals, though results remain classified under government security protocols. Advanced computer processing analyzes terabytes of observational data searching for patterns that might reveal the object's true nature, with some preliminary results being restricted from public release. The unprecedented scope and intensity of this global observation effort reflects both the scientific opportunity and the underlying concern about what humanity might be encountering in 3I/Atlas. Dawn of a new era. How has the discovery of 3I/Atlas fundamentally transformed humanity's approach to cosmic threats and our understanding of galactic dangers? This latest interstellar visitor marks a dramatic evolutionary leap in our species' ability to detect, analyze, and potentially defend against visitors from beyond our solar system. Advanced automated sky surveys including the Atlas Network, Pan-STARRS, Catalina Sky Survey, and the soon-to-be operational Vera Rubin Observatory have revolutionized interstellar object detection from once-in-a-lifetime events into regularly observable phenomena that require constant vigilance and rapid response capabilities. This technological revolution extends beyond simple detection to include sophisticated threat assessment protocols, international coordination mechanisms, and classified defense planning scenarios that acknowledge the potential for hostile interstellar visitors. The Pentagon's All-Domain Anomaly Resolution Office has quietly established new protocols for evaluating objects like 3I/Atlas, recognizing that future visitors might not be as apparently benign as current examples. Future space missions are already being planned to intercept or rendezvous with similar objects, potentially including defensive capabilities should such visitors prove threatening to human civilization. As global scientific and military institutions adapt to this new cosmic reality, humanity stands at the threshold of an unprecedented era where the mysteries of deep space directly impact planetary security and survival. The age of interstellar object research promises to fundamentally reshape not only astronomy and space science but also defense strategy, international cooperation, and our species' long-term survival planning for decades to come, as we finally acknowledge we are not alone in a potentially dangerous galaxy. As 3I/Atlas races toward its October encounter with our Sun, carrying secrets that could forever change humanity's cosmic perspective, one thing becomes clear: we are no longer alone in monitoring our solar system. Whether this visitor represents natural wonder or something far more extraordinary, we stand at the threshold of discoveries that may terrify and transform us. Stay tuned to Space Facts for the latest revelations about our mysterious cosmic visitor. What if the Big Bang wasn't the beginning but a rebirth? What if our entire 93 billion light-year observable universe is just a single object inside a much larger, older cosmos? This isn't science fiction, it's a possibility being explored by theoretical physicists, challenging our most fundamental understanding of existence. The clues might be hidden in plain sight, in the behavior of black holes and the baffling arrangement of the most distant galaxies spotted by the JWST. Let's explore this mind-bending possibility together. The standard Big Bang model. So, how did we arrive at our current picture of the universe? The story most of us know is the Standard Model of Cosmology, first mathematically conceptualized by the Belgian priest and physicist Georges Lemaitre in 1927. It states that our universe exploded into being 13.8 billion years ago from a point of extreme density. From this intensely hot state, space itself began to expand. Over billions of years, gravity sculpted this expanding cosmos, pulling matter together to form the vast, web-like structure of galaxies we observe today. This model is incredibly successful. It explains the faint afterglow of the Big Bang, the cosmic microwave background, and it accounts for the accelerating expansion of the universe. This acceleration, confirmed in 1998, is often attributed to dark energy, which makes up about 68% of the universe. When combined with dark matter, at around 27%, it appears 95% of our cosmos is made of stuff we can't see or understand. This means that all the stars, planets, and galaxies we can observe make up a mere 5% of reality. The bottom line is the Standard Model, for all its successes, leaves us with the biggest questions in science completely unanswered. The black hole universe theory. What if there's a more elegant explanation, one that doesn't require inventing new particles or mysterious forces? A radical alternative, championed by physicist Nikodem Poplawski, proposes that our universe was born inside a black hole within a much larger parent universe. This idea flips our perspective on cosmic origins entirely. Instead of a singularity appearing from nothing, the theory suggests a physical process, the gravitational collapse of matter in a parent universe. Think of it like a star many times the mass of our sun collapsing to form a black hole, but on a cosmic scale. In this model, what we perceive as the Big Bang was actually the moment our universe formed inside that parent black hole. This framework elegantly resolves the issue of what came before the Big Bang, as the parent universe provides a clear preceding state. This cyclical model redefines our cosmic address, demoting our entire universe from everything that is to just one bubble in a potentially infinite cosmic foam. It also provides a physical source for the energy and matter in our universe, sourcing it directly from a pre-existing parent cosmos. In essence, the matter that makes up you, me, and the stars didn't appear from nothing, but was recycled from a previous cosmic iteration. Quantum mechanics and degeneracy pressure. Here's where things get really interesting, and it hinges on a core principle of quantum mechanics. Have you ever wondered what stops a dead star from collapsing forever? The answer lies in a rule established by the brilliant Austrian physicist Wolfgang Pauli. His exclusion principle states that identical particles, like electrons, cannot occupy the exact same quantum state at the same time. When gravity tries to crush matter into an incredibly small space, this principle creates a powerful outward push known as degeneracy pressure. The more you squeeze, the harder the particles push back. This is the force that supports white dwarfs against collapse, where matter is packed to a density of over 1 million kilograms per cubic centimeter. In even more extreme objects like neutron stars, the pressure is even greater, holding up against densities of over 100 trillion kilograms per cubic centimeter. This pressure is fundamentally different from thermal pressure, which supports a star like our sun, as it doesn't depend on temperature at all. Proponents of the black hole universe theory argue that this same quantum pressure could operate on the scale of an entire collapsing universe, offering a mechanism to avoid the infinite singularity. The bounce mechanism. So, if a universe collapses, what happens when this quantum pressure kicks in? Instead of crushing down to an infinite point, a singularity where physics totally breaks down, the collapse could actually halt and then rebound. This is what's called the Big Bounce, a concept that's been heavily explored in loop quantum cosmology by physicists like Martin Bojewald. In this scenario, as the matter from a parent universe collapses, it gets really close to the maximum density allowed by physics, which is called the Planck density. That's about 5.1 times 10 to the 96 kilograms per cubic meter, which is, honestly, just mind-blowing. At this extreme, quantum gravity effects become so powerful that they basically overwhelm everything else. This force stops the collapse in its tracks and triggers a massive, explosive rebound. The rebound itself would be incredibly brief but unbelievably violent. Essentially, it resets the cosmic clock for a brand new universe. For any observer inside this newly expanding region, the rebound would look and feel exactly like a Big Bang, and it might even preserve information from the previous cosmic cycle. Interestingly, this bounce could also offer a potential solution to the black hole information loss paradox, which is a major conflict between general relativity and quantum mechanics. The paradox is all about what happens to the information about matter that falls into a black hole if the black hole eventually evaporates. A bounce mechanism suggests that this information isn't destroyed, it's actually carried through the rebound event into the new universe, preserving the fundamental laws of physics. Evidence from early galaxies. This might all sound like fascinating speculation, but where's the evidence? Well, it might be hiding in the deepest images of our universe, captured by the James Webb Space Telescope. According to the standard model, galaxies should build up gradually over time. But JWST is finding galaxies that are, honestly, bafflingly massive and mature. For example, the GLASS JWST Early Release Science Program, which includes astronomers like Rohan Naidu, has identified galaxies such as GLASS Z12 at a redshift of 12. That means we're seeing them as they were just 350 million years after the Big Bang. These galaxies are already 1 billion times the mass of our Sun, which is way larger than our models predicted was possible so early on. And to make things even more puzzling, these ancient galaxies seem to host supermassive black holes that are millions of times the Sun's mass, a phenomenon that standard models really struggle to explain so soon after the Big Bang. The Big Bounce model, however, offers a potential explanation. It suggests these black holes could actually be relics that survived from the previous cosmic era, acting as gravitational seeds for the next round of galaxy formation. Galaxy rotation mystery. Now let's talk about another cosmic puzzle that might just point to the same conclusion. In a random and uniform universe, you'd expect galaxies to be spinning in all sorts of directions, with a roughly 50-50 split between clockwise and counterclockwise rotations. But that's actually not what we see. A study from 2020, which analyzed over 200,000 spiral galaxies and was led by computational astronomer Lior Shamir, found a significant imbalance. There seems to be a preferred direction of spin, an alignment that stretches across vast regions of the cosmos. The odds of this asymmetry happening purely by chance are less than 1 in a billion. This unexpected alignment, seen across billions of light-years, suggests that the processes during the universe's formation weren't as random as we once thought. This large-scale pattern actually challenges the long-held assumption that the universe is the same in all directions, which is a principle that underpins pretty much all our cosmological calculations. And this isn't just a small localized effect. The pattern of cosmic spin is coherent across billions of light-years. Shamir's analysis shows that the distribution of spin directions fits what's called a dipolar pattern, meaning it has a distinct north and south pole, kind of like a spinning magnet or a planet. Creating such a large-scale, coherent structure after the Big Bang would be extremely difficult, which points instead to a fundamental property that was imprinted on the universe right at its very creation. Schwarzschild cosmology. So, this idea of a universe inside a black hole isn't entirely new. It actually falls under a concept known as Schwarzschild cosmology. The name comes from Carl Schwarzschild, who, way back in 1916, found the first exact solution to Einstein's field equations. That solution describes the spacetime around a spherical mass, what we now call a black hole. The model suggests that the observable universe is, in fact, the interior of a black hole existing within a larger parent universe. From our perspective, the Big Bang was the formation of this black hole, and, from the outside, our entire cosmos would just look like a regular black hole. The size of this black hole's event horizon is defined by the Schwarzschild radius, and for a universe with the mass of ours, this radius is remarkably close to the radius of our observable universe. Mathematically, the singularity at the beginning of our universe is similar to the singularity at the center of a Schwarzschild black hole. The edge of our observable universe, a sphere with a diameter of 93 billion light-years, acts much like a black hole's event horizon, a boundary from which light cannot escape to an outside observer. Black holes as universe creators. Let's take this idea to its logical conclusion. If our universe was born inside a black hole, what does that imply about the estimated 100 million stellar mass black holes in our own galaxy? It suggests that each and every one could be a gateway, a seed for a new baby universe. This paints a picture of a vast cosmic ecosystem, a multiverse where universes are constantly being born. This concept, known as cosmic natural selection and explored by physicist Lee Smolin, could even offer an explanation for the fine-tuning problem, the mystery of why the fundamental constants of physics are so perfectly set for life. If universes are constantly being created, then perhaps only those whose physical laws allow for the creation of stable black holes can themselves reproduce, leading to a multiverse dominated by life-friendly universes. This theory proposes that our universe is so adept at creating black holes precisely because it was born from one, continuing an unending cosmic lineage. Smolin's theory suggests that the physical constants, like the strength of gravity or the mass of an electron, could slightly mutate with each new universe born from a bounce. Universes with constants that are better at producing black holes will have more offspring, and over countless generations these properties will become dominant. This makes the fine-tuning of our universe for life not a lucky accident but a predictable outcome of cosmic evolution on an unimaginable scale. Torsion and space-time twisting. For a universe to bounce instead of collapsing into a singularity, you need a powerful repulsive force at extreme densities. One candidate for this force comes from an extension of general relativity known as Einstein-Cartan theory. The mathematics behind this were developed in the 1920s by the brilliant French mathematician Élie Cartan. This theory incorporates a property of space-time called torsion, which accounts for the intrinsic spin of fundamental particles. This spin is a fundamental quantum property like mass or charge that gives particles an inherent angular momentum. In standard general relativity, space-time can bend, but it cannot twist, making the inclusion of torsion a significant modification needed for this theory to work. According to physicists like Nikodem Poplawski, at the densities found inside a black hole, the interaction between torsion and the spin of particles would create a powerful repulsive force. This torsion-induced bounce would be the mechanism that creates a new universe inside every black hole, making them not just cosmic destroyers but creators. Cosmic anisotropy. The evidence for a preferred direction in galaxy spins points to a concept called cosmic anisotropy, the idea that the universe is not the same in all directions. This directly challenges the cosmological principle, a foundational assumption in modern cosmology. This isn't just about galaxy spins. Anomalies in the cosmic microwave background radiation, first noted in data from the WMAP satellite and later confirmed by the Planck satellite, also suggest a large-scale alignment. Physicist João Magueijo famously dubbed this the axis of evil because it aligned with our solar system's plane, a result so strange it had to be a mistake, except it kept showing up with a statistical probability of being random at less than 0.1%. These anomalies, once dismissed as statistical flukes or errors in measurement, are now forcing a re-evaluation of fundamental assumptions, which is exactly how science progresses. The cosmological principle of isotropy has been a cornerstone of cosmology for nearly a century, so challenging it is met with significant scientific skepticism. However, as observational data from projects like the Sloan Digital Sky Survey and the Planck satellite becomes more precise, these persistent anomalies are becoming harder to ignore. If the universe truly does have a preferred direction, it would force us to rewrite our most basic models, and would strongly imply an origin story that involves rotation, just as the black hole universe theory predicts. From the impossible galaxies seen by JWST to the mysterious alignment of galactic spins, we are faced with observations that don't quite fit our standard story of the cosmos. The idea that our universe is inside a black hole, born from a cosmic bounce, offers a potential framework to explain these anomalies without inventing new physics. It suggests we might be part of an endless cycle of creation. What do you think? Are we living inside a black hole? Let me know your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell icon. Thank you for watching Space Facts. What if the most profound discovery in human history was made, and then deliberately buried? We're not talking about rumors or grainy photos. We're talking about 24 gigabytes of classified NASA data on an interstellar visitor that defied the laws of physics. Data leaked by a ghost-like hacker group, revealing a 26-kilometer-wide object that wasn't just passing through our solar system, but actively navigating it. This is the story of 3I Atlas, what NASA allegedly found and why they never wanted you to see it. Let's delve into the data. Event Horizon cyber attack. How does a secret stay buried in the digital age? Sometimes, it doesn't. In the dead of night on September 2nd, 2025, a hacker collective calling themselves Event Horizon executed a flawless cyber attack on NASA. They didn't just knock on the door, they dismantled it. By exploiting a zero-day vulnerability in an outdated mission planning module, they bypassed layers of federal firewalls. Security logs, later leaked themselves, show a terrifying timeline. At 3:14 a.m. Eastern, initial access was gained. By 3:19 they had escalated their privileges to the highest level. At 3:23, the exfiltration began. In less than 7 minutes, 24 gigabytes of compressed files were siphoned from a secure server containing mission telemetry, internal communications, and top-secret analysis on Object 3Y Atlas. By 3:30, they were gone. The attackers left no signature, no digital fingerprints, only a silent void in the server logs where critical audit trails should have been. The specific target was a data archive tied to the Deep Space Network, containing the most sensitive raw telemetry. NASA's internal cyber forensics team was left with nothing but a clean exit, a ghost in the machine that had walked out with the crown jewels. The manifesto and distribution. A data breach is one thing, but a declaration of war on secrecy is another. Within hours of the hack, a manifesto from Event Horizon appeared on encrypted forums. Their message wasn't a boast, it was a justification. They claimed the breach was a direct response to what they termed unlawful cosmic secrecy, arguing that discoveries of this magnitude belong to humanity, not to a select few government agencies. The manifesto warned that the stolen files contained information so sensitive even senior directors at NASA were allegedly unaware of its full scope. Their language was direct: the world deserves to know what its own scientists have found. To prove their point, they began a strategic distribution campaign. Blurred screenshots and heavily redacted memos were sent to journalists and channels known for covering classified science. They specifically avoided mainstream outlets, opting for platforms that would analyze the data without an institutional filter. This drip feed of information created a groundswell of speculation that legacy media couldn't ignore, forcing the conversation into the open on Event Horizon's terms. Authenticating the documents. How can we be sure these leaks are real? The proof is in the details. The screenshots that flooded encrypted channels are layered with evidence of their origin. Documents are stamped confidential in bold block letters. Metadata tags show a 0314 UTC timestamp, matching the breach window from NASA's own security audit. A mission patch appears in the corner, a stylized comet streaking past a NASA vector, flanked by the code 3I Atlas int. One partially blurred memo lists the object's trajectory with terrifying numbers, hyperbolic v-infinity of 26.1 kilometers per second and an eccentricity, or E, of 6.2. These figures confirm an interstellar origin at a speed that defies simple explanation. Another screenshot shows a status log from the intercept team. Most text is blacked out except for a single phrase: plume anomaly flagged at T plus 11.3 seconds. The documents include FITS file headers for raw imaging data and internal routing codes for JPL's document management system. These are the kinds of mundane, technical details that are nearly impossible to fake convincingly. Discovery of 3I Atlas. Before the leak, there was the discovery that started it all. On July 1, 2025, the Asteroid Terrestrial Impact Last Alert System, or ATLAS survey in Hawaii, logged a new object tearing into the solar system at 130,000 miles per hour. Astronomers flagged it immediately. This was no ordinary comet. The object, soon labeled 3Y Atlas, measured an estimated 26 kilometers across, roughly the size of Manhattan, moving faster than any object ever observed inside the orbit of Jupiter. Veteran survey scientist Dr. Lina Takahashi, a fictional name from the leaked files, was quoted in a log. The track was so steep, the software flagged it as an error. Within hours, observatories from Chile to Arizona confirmed the numbers. The object's incoming speed of over 58 kilometers per second defied the sun's gravitational grip. Its trajectory pointed back toward the constellation Lyra, far from the ecliptic plane where most solar system debris resides. To put its size in perspective, the asteroid that killed the dinosaurs was only about 10 kilometers wide. This was over twice that, and it wasn't from around here. Impossible physics and trajectory. Here is where the data gets terrifying. The trajectory of 3I Atlas was not just interstellar, it was unnatural. Calculations from the Minor Planet Center confirmed by JPL revealed an orbital eccentricity of over 6. For context, most comets from our own Oort cloud barely reach an eccentricity of 1.0. Our first interstellar visitor, Oumuamua, had an eccentricity of 1.2. A value of 6.2 means the object was moving on an almost perfectly straight line at a velocity that gravity could barely alter. But the most damning piece of evidence detailed in the leaked mission logs was a sudden, unexplained sideways acceleration on July 18, 2025. it was a course correction. The object wasn't just flying, it was steering. The maneuver required a change in velocity, or delta V, that would have required gigatons of force to achieve on an object of this mass. All natural explanations, outgassing, solar radiation pressure, even a gravitational assist from an unknown planet, were systematically modeled and ruled out by JPL's top analysts. The physics simply didn't work unless the push came from within. Surface anomalies. The armor problem. What does a 26-kilometer object from another star system look like? The first leaked images from the Intercept mission were paradigm-shattering. 3I Atlas's surface resembled no comet on file. Imaging analysts flagged a pattern of smooth, almost metallic-looking plating, broken by lines that ran too straight to be natural fractures. One analyst, quoted in a redacted chat log, called it the radiator problem, referring to a gridwork of raised ridges spaced like the cooling fins on spacecraft. These ribs cast long uniform shadows, and their regularity caused the anomaly detection software to flag the pattern as artificial. Comparisons to known comets like Halley or 67 P Churyumov-Gerasimenko fell apart. Their surfaces are jagged and chaotic. 3I Atlas, in contrast, had long stretches that reflected sunlight like polished alloy. Further spectral analysis of this reflected light showed an albedo inconsistent with any known meteoritic iron, lacking the usual chondritic features. It was too smooth, too reflective, and far too structured. Thermal signatures and heat pulses. This is where the data points directly to active technology. Martin Cordner's team at Goddard Space Flight Center, a name appearing in the leak, got a full infrared spectrum of 3I Atlas. The data was so sensitive it was sealed within hours under a restricted embargo. The logs show the Webb Telescope's infrared array recorded heat vents pulsing with the regularity of a clock every 90 seconds. Heat would pool along the radiator seams and then burst outward in tight, directed jets, not the broad, chaotic outgassing of a comet. The mission logs label this a directive motion event, a term usually reserved for spacecraft thrusters. More disturbing, trajectory analysts correlated these thermal pulses with the object's subtle course corrections. Each 90-second heat pulse matched a tiny, precise adjustment needed to maintain its hyperbolic escape route. The focused nature of these thermal events implies the existence of engineered nozzles or vents, as a natural body's heat would dissipate uniformly across its surface according to the laws of thermodynamics. This was controlled, focused, and undeniably artificial. Chemical composition mysteries. The mystery only deepens when you look at what 3I Atlas was made of. Martin Cordner's team at Goddard was the first to get a full spectrum after the Intercept, and the results were an instant red flag. The early spectra lit up with incredibly sharp, bright lines of nickel. In cosmic bodies, nickel almost always rides shotgun with iron. Yet in every single frame of data from 3I Atlas, iron was almost completely absent. Its signature spectral lines were missing. This isn't just rare. In the entire catalog of known comets and asteroids, it's unheard of. The natural formation processes that create asteroids from protoplanetary disks simply don't separate these two elements with such purity. Leaked notes suggest the isotopic ratio of the nickel was also wrong, indicating it wasn't formed in a typical supernova. The purity level was estimated to be over 99.8%, a level that on Earth requires an advanced electrochemical process known as the Mond process. Radio echoes and communication patterns. Did we ever try to listen? According to the leaked files, yes. And what we heard was terrifying. While public-facing projects might report silence, the classified logs from the Deep Space Network told a different story. Radio astronomers reviewing the Intercept mission's raw data flagged a pattern that shouldn't have been there, faint, repeating echoes bouncing back from the object at regular intervals. These were not natural radio bursts or cosmic static. They were precise, clipped signals echoing at intervals that mapped almost perfectly to the 90-second timing of the object's thermal pulses. A veteran telemetry specialist named Marissa Singh, in a chat log later leaked by Event Horizon, wrote, "It's like someone is pinging the probe and it's answering. The pattern is too tight for random noise." The return signal wasn't a simple reflection. It was modulated, carrying a complex phase shift. It was, for all intents and purposes, a reply. This suggested the object was not just passive, but an active system processing and responding to incoming stimuli. Expert analysis and propulsion theory. You can't discuss these anomalies without bringing in a voice of scientific courage like Avi Loeb. The Harvard astrophysicist, who famously staked his reputation on Oumuamua being alien technology, wasted no time weighing in on the 3I Atlas files. He argued the intercepted telemetry read like a blueprint for an advanced propulsion system. Each 90-second heat pulse and corresponding course correction was perfectly consistent with a massive ion drive or a similar engine. In Loeb's words, if you wanted to navigate through a solar system while managing heat and energy, you would use timed directional thrust. That is what the data shows. But the most jarring evidence was a fragment recovered by the interceptor's dust collector. A leaked lab memo described a fleck of material with a lattice of silicon and doped phosphorus, arranged in layers spaced at micron intervals. The structure was noted as being radiation-hardened to a degree far beyond current human capability, suggesting it was built for long-duration travel through the harsh interstellar medium. This wasn't just a circuit, it was an artifact from a civilization far beyond our own. So what does this all mean? We have a fictional but detailed account of an interstellar object, 3I Atlas, discovered in 2025. And we have a leaked cache of alleged NASA documents that point to a disturbing conclusion, that the object was a piece of technology. Metallic armor, rhythmic heat pulses that act as thrusters, refined nickel, and structured radio echoes all point to an artificial origin. The most shocking piece of evidence, a microscopic fragment that resembles a computer chip, pushes this story from science fiction into something far more unsettling. While the leak itself is part of this narrative, it forces us to ask a terrifying question. What if our first definitive contact isn't a message but a 26-kilometer machine flying silently past our window? The truth is still out there. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the secrets of science and technology. Thanks for watching InnoVision Tech. A cosmic alignment so perfect it defies chance, or a deliberate arrival we were never meant to see. On September 12, 2025, astronomers witnessed the impossible. Two colossal objects arriving from opposite ends of the universe, set to rendezvous in our solar system during a total observation blackout. The official story is twin comets, but the evidence points to something far stranger. Let's explore this together. Swan's dramatic arrival. What if a new object appeared in the sky tonight so large it dwarfed everything we've seen in a generation? That's exactly what happened on September 12, 2025. Data from the Solar Wind Anisotropies or SWAN instrument, a wide field camera aboard the SOHO spacecraft, revealed a bright, unmistakable object blazing through the solar system. The initial readings were staggering. Its tail stretched nearly 2.5 degrees across the sky, which is about 5 times the width of a full moon. For a newly discovered comet, this scale is almost unheard of. For comparison, the famous comet Hale-Bopp's tail was about as wide at a similar distance. Initial photometry clocked it at a magnitude of 7.4, a brightness level that makes it an easy target for backyard telescopes and even powerful binoculars. The news spread like wildfire, and amateur astronomers scrambled to confirm what the satellite had seen. Just 2 days later, an observer in Australia captured a dramatic image showing a streak of light so immense it barely fit in the camera's frame. The immediate reaction wasn't just excitement, it was disbelief, as the object was already outshining professional predictions by a factor of 4. This was no ordinary icy visitor. The sheer size and luminosity didn't match any recent precedent, forcing comparisons to legendary comets of the past. Official recognition and growing mystery. A name makes it real but can also deepen the mystery. By September 13th, the International Astronomical Union's Minor Planet Center made it official, designating the object C/2025 R2 or SWAN in honor of the instrument that found it. Within a single weekend, the global astronomy community, from professionals using the Hubble Space Telescope to amateurs in their backyards, was completely fixated on this celestial titan. They traded images and brightness measurements across hemispheres, trying to make sense of its unprecedented behavior. Most comets discovered in the modern era are faint smudges requiring powerful telescopes, but SWAN was a spectacle for anyone who knew where to look. Its magnificent tail sliced through the constellation Virgo at a blistering pace of 20 arc-seconds per minute, growing brighter with each passing day as it raced toward the sun. The conversation quickly shifted from simple observation to intense speculation, with astronomers like Dr. Robert Warwick, the discoverer of Oumuamua, noting the statistical improbability of such a bright object appearing with so little warning. The amateur community, often the first to notice unusual behavior, was already debating what could possibly power a tail this long and this bright. It was simply too big, too vivid, and too fast to be ignored. The cosmic coincidence. Some things are too perfect to be random. C/2025, R2 or SWAN wasn't the only newcomer drawing attention. Just days before its discovery, another object, the Interstellar 3 I/Atlas, was already on its way in, approaching from a completely different sector of the sky. SWAN's path originated from the direction of Aquarius, while Atlas emerged from Sagittarius. On a star map, their arrival vectors are separated by more than 100 degrees of the sky. And yet, both are scheduled to reach perihelion, their closest point to the Sun, within the same 10-day window in October. SWAN will arrive around October 20th at a distance of about 1 AU, the same as Earth's orbit. Atlas will skim past the Sun just 3 days earlier on October 17th, at a distance of roughly 1.36 AU. This puts their perihelion points only about 50 million kilometers apart, closer than Mars ever gets to Earth. Their orbital geometry is just as striking. Both are on steeply inclined paths, with SWAN tilted over 60 degrees and Atlas at a near-polar 85 degrees to the plane of our solar system. According to experts like Dr. Paul Chodas at NASA's Center for Near-Earth Object Studies, the odds of two such objects from such different origins, arriving in near-perfect synchrony, are vanishingly small, estimated at less than 1 in a billion. Atlas breaks the rules. So what happens when an object just, flat out refuses to follow the laws of physics as we know them? Well, that's exactly what happened with 3 I/Atlas, which first caught astronomers' attention by, honestly, breaking all the rules. Early spectrographs from the Atacama Large Millimeter Array reported something that set off alarms everywhere. A body dominated by nickel with virtually no iron, a ratio that's pretty much unheard of in natural celestial objects. This completely contradicts everything we know about comets and asteroids, which almost always contain iron-nickel blends, similar to chondritic meteorites. The claim was so radical, some labs immediately called for data re-verification, just to make sure there wasn't some kind of mistake. But the mystery only deepened when its coma was found to be pumping out carbon dioxide, detected at a strong 4.3 micron spectral line, at rates 5 times higher than water. And what really couldn't be explained was its motion. Observers noted 3 distinct, non-gravitational accelerations, each providing a delta V of several meters per second. These weren't the gentle pushes from solar heating, they were sharp, sudden bursts, almost as if the object had fired a thruster. The only other object to show similar acceleration was Oumuamua, but as Harvard astronomer Avi Loeb pointed out, the pulses from Atlas seemed far more controlled and powerful. SWAN, the fortress. One object acts like a drone, the other like a battleship. C2025 R2 or SWAN is honestly in a league of its own. Its sheer scale is breathtaking, but it's really the finer details that have experts truly puzzled. The first whispers of something strange began with reflectance data showing an unusually high albedo or reflectivity of 0.6, similar to fresh snow. That's wild considering typical comet nuclei are darker than asphalt, with albedos below 0.05. Some amateur spectroscopists even argue the data matches a nickel-cobalt alloy, a material we use on Earth for its immense strength and resistance to corrosion. This is what led to the term nickel-cobalt hull popping up in online forums. Then came reports of an optical anomaly, a persistent silvery halo around the nucleus that seemed to shimmer. Some experts theorize this could be a plasma envelope or a mini magnetosphere, acting as an electromagnetic shield. That's actually where the nickname the Fortress comes from. Unlike the agile Atlas, SWAN moves like a tank, slow, steady, and honestly, seemingly invulnerable. Its record-breaking tail also shows evidence of micro-thrusts, tiny, rhythmic pulses that suggest precision course corrections, which are way too regular to be just random outgassing from surface fissures. Mission theories. Coincidence, or a coordinated mission? When a long-period object on a 22,554-year cycle and a hyperbolic interstellar object arrive together, the odds of chance really start to plummet. This has fueled a whole wave of mission theories. The first, and probably the most routine, is a scheduled refueling run, with the Sun acting as a cosmic pit stop for 2 engineered probes. A second, Less peaceful theory suggests an intervention or a confrontation, especially when you consider the incredible power levels required for their observed accelerations. A third theory, championed by thinkers like Dr. Avi Loeb, proposes an audit chain. Oumuamua, or 1I 2017 U1, was the first scout, followed by 2I Borisov, and now Atlas and Swan represent escalating responses to Earth's century of radio transmissions. Each new arrival would be a more complex probe sent to check in. In every scenario, the sun isn't just a backdrop, it's the rendezvous point, the power source, and the beacon. The idea of using a star for a gravitational assist or an energy top-up is standard practice for our own probes, like the Parker Solar Probe, which honestly makes this theory chillingly plausible. Ancient connections. Could our history be written in the stars, just waiting for the right moment to be read? Swan's enormous 22,554-year orbit is, a direct link to the last ice age. Its last visit to the inner solar system would have occurred around 20,000 BCE, a time of immense climate change when human civilization was really in its infancy. This same epoch left its mark in the ice cores of Greenland and Antarctica, where layers of dust hint at dramatic celestial events. At the heart of this idea is Göbekli Tepe, a mysterious site in Turkey built around 9600 BCE. Its stone pillars are carved with symbols, and some of these are interpreted by researchers like Martin Sweatman as depictions of comets. His controversial analysis of Pillar 43, the Vulture Stone, suggests it records a catastrophic comet impact that triggered a mini ice age. Mainstream archaeologists and astronomers strongly caution that these connections are speculative. Still, the timing is, well, hard to ignore. Swan's last passage happened just as human culture was taking its first steps toward tracking the heavens and building monuments, leaving open the tantalizing possibility of a forgotten history. The blackout window. Just as things get interesting, the lights go out. From October 8th to 18th, both Swan and Atlas will pass through solar conjunction, meaning the sun's glare makes them impossible to observe for optical telescopes on Earth. This affects every major observatory, from the Very Large Telescope in Chile to the Keck Observatory in Hawaii, as the objects will be within a solar elongation angle of fewer than 5 degrees. This is a normal astronomical occurrence, but the timing is incredibly convenient. Rumors are circulating of internal memos from agencies like US Space Command and the European Space Agency, directing teams to suspend high-resolution imaging. Proposals for alternative observation methods have allegedly been denied, and raw data requests delayed. A handful of telescope allocation reviewers, speaking off the record, have described explicit orders to avoid public statements. The result is a forced silence at the exact moment when the two most anomalous visitors in modern history make their closest approach, leaving a frustrating and highly suspicious gap in the data. Underground resistance. When official channels go dark, the people light the way. The observation blackout may have silenced government agencies, but it sparked a fire in the global community of independent astronomers. Bill Gray, a veteran tracker renowned for his open-source orbit calculations, rallied a distributed network of backyard observers and small observatories. His call to action spread across forums with a clear message: keep your scopes on the sky, log every flicker, and share the raw data. In Europe, amateur collectives began pooling wide field sensor feeds, while leaks from private groups suggested makeshift plans to bypass the blackout using radio telescopes, like the Allen Telescope Array, hoping to detect emissions from the objects themselves. With big institutions locked down, this grassroots effort, relying on publicly available data from surveys like the Zwicky Transient Facility, has become the only real-time source of information. It's a testament to the power of citizen science. If we're going to get answers, they might just come from someone's backyard, not a government lab. Power estimates and implications. Let's talk about the energy because the numbers are staggering. The biggest red flag for both objects is the power source required to explain their behavior. If the observed accelerations of Atlas are indeed powered by thrusters, the energy output would need to be on the order of 10 gigawatts. That's the equivalent output of 10 large nuclear power plants, like the Palo Verde generating station. But Swan makes that number look insignificant. Based on its size, brightness, and the micro-thrusts detected in its tail, the most extreme estimates place its power output at a mind-boggling 10,000 gigawatts or 10 terawatts. That is more raw power than the entire energy grid of planet Earth combined. From a physics perspective, as noted by futurists like Dr. Michio Kaku, such energy control would place its creators firmly on the Kardashev scale as a Type 1 or even Type 2 civilization. These figures push the conversation beyond academic debate and into a realm that forces us to question everything we thought we knew about our place in the universe. Here's the bottom line. Two of the most anomalous objects ever detected have entered our solar system on a synchronized path. Their composition and behavior defy our current understanding of comets, and their arrival coincides with an official observation blackout that has silenced the world's most powerful telescopes. We are left with a grassroots network of citizen scientists working to uncover the truth and energy readings that point not to nature, but to technology. Whether this is a cosmic coincidence, a peaceful rendezvous, or something else entirely, we may soon find out when they emerge from the sun's glare. The only question left is, what will we see when they come out the other side? Don't forget to like, subscribe, and hit the bell icon for more updates on this developing story. Thank you for watching Space Facts.